Let's talk about different notations for writing domains and ranges. Okay, we're going to start with a little set notation. Okay, a collection of items can be a set. Usually in math we talk about a collection of numbers, but it doesn't have to be numbers. I could have a set C of all clothes. And in that set, which begins with a curly brace, I would list the elements of that set. All right, so pants are clothes, so that would go in set C. Shoes are clothes, that would go in set C. These elements are separated by commas. Okay, and if the set is goes on and on, usually this means is infinite. Then you would put an ellipse there, meaning that there are more elements in that set that you're just not listing. Okay, and then you would close it with another curly brace. So I could say I have another item, a hat, and this hat is an element of set C. It belongs in set C. So this little symbol here means is an element of. Okay. So that's sort of how we write out elements of sets, and this is the notation that we're using. Some common sets that we are going to reference today and in the future is this double R, this double lined R. If I'm doing handwriting, I would write it like that probably, okay? And that is the set of all real numbers. Okay, so I could list all kinds of elements of this set. I could say that 1 is in R because 1 is a real number. I could say that pi is in R because pi is a real number. Okay, the other set that I'll reference in this video is this Z, which is the set of all integers. And the way I'm going to write that, just so you can see different kinds of notations here, is I'm going to start there because the integer set is infinite. And I'm going to say -3, -2, -1, 0, 1, 2, and then dot, dot, dot just means continue on in that fashion. So that's one way of listing the set of all integers, okay? And I could say that -7 is an integer. So -7 is in set Z. All right, that's how that works. So let's look at different ways to write intervals, because that's what this is mostly referring to. So if I have this interval right here where I'm trying to represent this line that's shown on this number line, in Algebra 1 you would use an inequality and you would say x is greater than or equal to -1 and less than 2. All right, and you would use greater than or equal to because of this closed dot right here, and you would use strictly less than 2 because of this open dot right there. All right, you have a closed interval or an open interval, and we can say that the interval is inclusive if the dot is closed, okay, and not inclusive if the dot is open. So that's how you write that in inequality notation. If I wanted to write that in interval notation, all right, this is my favorite notation. If I want to write that in interval notation, I'm still going from -1 to 2. I represent an inclusive endpoint, all right, a closed dot with a square bracket. So this means closed. And I represent an open dot with an open parenthesis. This means open. Okay, so the closed bracket goes with the closed dot, and that means inclusive. And the open bracket goes with the open dot, and that means not inclusive. And the symbol that would go with this is the less than. And the symbol that would go with this is the less than or equal to. Okay, these three things represent an inclusive endpoint, or a way to include the number that you're listing. Set notation is just a fancy way of writing inequality notation. Okay, set notation is just determining the set that you're drawing from. So for this one, we would say we are looking at all the x's in the real numbers such that this inequality is true, such that x is greater than or equal to -1 and less than 2. Okay? Same information as inequality, just a little more formal, all right? This line means such that. Okay? And here, this section right here just tells you what set you're drawing from. Some textbooks will not put the in the real number part, they will just put x, and it is assumed that you're drawing from the real numbers. Okay, let's look at another one. All right, so if I were looking at this one for the inequality notation, I would say, well, x is greater than -3 and less than or equal to 2. For the interval notation, I would say, well, I'm going from -3 to 2. -3 is not included, and 2 is included. And then for the set notation, I would say, I'm looking at the set of all x's. Here I'm going to assume that it's in the real numbers. You should be comfortable with that r there or without it. All right? The set of all x's such that x is greater than -3 and less than or equal to 2. Okay, all three of these notations mean the same thing. I like this one the best because it's short, it's concise, it comes in handy a lot. Sometimes you're going to have an infinite interval, all right, an interval that doesn't really have a starting spot. If you're in inequality notation, it is enough to say that x is less than or equal to 2. And that describes this whole line, all the numbers less than or equal to 2. If you're in interval notation, though, it is not enough to just say that this interval ends at 2. You need to have a starting spot. So it's good to know that I'm ending at 2. The way I'm going to write the start, because there is no starting spot, I'm going to say it starts at -infinity. Okay? Now, -infinity is a concept. It's not a number. It's just how we represent the very beginning. All right, so we're going to say that this is open. I can't ever reach -infinity. I can't include -infinity in any way. So for infinite intervals, in the interval notation, you need the -infinity as your starting spot. In inequality notation, you might see someone write that this is greater than -infinity, but that is extra information that's not necessary, and it just makes it messy. I would ask that you not put infinities in your inequality notation, okay? X is less than or equal to 2 is good, and you don't want that extra information of infinity. It's already implied, all right? The set notation for this is all the x's such that x is less than or equal to 2. Now, this is when inequality notation sometimes gets a little bit unwieldy. Maybe not, we'll see. All right, so I have two intervals that I have to represent right now. I can say that this is all the x's less than 3 and, well, or all the x's greater than or equal to 6. And if you remember conjunctions and disjunctions, this is a disjunction. It's either in this interval or it's in this interval, okay? In interval notation, I want to be able to describe both of these intervals. So I'm going to connect them together. I'm going to say my first one goes from -infinity to 3, open. And I'm going to use this U. This U means union, and it's how you join two intervals together. Union closed 6 to +infinity. Okay, this is the interval notation if you have more than one interval, and you can join as many intervals together as you want. Every time you have a new section, you just put a U in between them. So this tells me that I'm going to go from -infinity to 3. I'm going to have an open dot on 3, and then I'm going to join it with a closed dot on 6 and continue on all the way to infinity. In set notation, you would say, all right, I have a closed bracket. I'm looking at all the x's such that x is less than 3 or x is greater than or equal to 6. And then close my set. Okay. Finally, we can find the domain and the range using all these notations. In inequality notation, the domain of this starts here and goes all the way forever. So I would say that x is greater than -1. It starts at -1 and then keeps going forever. This arrow means it's going to keep going, so it's going to eventually hit all my x's. Okay. The range for this, range goes from bottom to top. So if I'm looking at the range for this, I would say I'm starting here all the way down at the bottom, and then the highest I go is this point right here at 2. So the range is all the numbers less than or equal to 2. And you can assume that this is an inclusive point here at the top unless you see an open circle. Okay, if you don't see an open circle, then any number, any value on a line is including that value. All right, that's it in inequality notation. In interval notation, we have the same information. I just want to say that the domain goes from -1, not included, all the way to infinity. The range goes from -infinity up to 2 included. Okay. Set notation, the domain is the set of all x's, and you can say in the real numbers, such that x is greater than -1. And the range, now be careful here, is the set of all y's in the real numbers, such that y is less than or equal to 2. And I said to be careful here, but I wasn't careful up here. Look at that. I put an x instead of a y. Range is y's, so let's make sure that you're using a y and not an x when you're talking about range. Okay, so domains are x's, they're going left to right. Range is y's, it's going up and down.